Hi, I'm Daniel Campos Zamora. On behalf of my co-authors, I'll be presenting our work, MoiréWidgets, High Precision, Passive Tangible Interfaces via Moiré Effect. Tangible User Interfaces, or TUIs, provide tactile and proprioceptive feedback which improves task comprehension, speed, and precision, making them well suited for a variety of applications, including music and video editing, 3D modeling, digital sketching, and augmented reality. However, they are typically made with electronic circuits requiring wired power or batteries to operate, which can make them expensive to produce and also increases their environmental impact. Consequently, researchers have explored battery-free and passive TUIs using a variety of sensing modalities. For example, researchers have used sound and acoustics to register inputs, 3D printed conductive materials to add tactile controls to touchscreens, and also used RFID and magnets to register inputs. However, many of these systems require close coupling between the widgets and a central computing device like a smartphone, which limits their working range, or require complicated antenna and receiver setups to work. Conversely, vision-based systems use cameras that are ubiquitous in smartphone devices and can track free-moving objects. However, they may depend on predefined libraries of tags which are hard to customize and adapt to 3D objects, and their sensing resolution may be limited at greater distances. Our method uses a commonly observed but powerful optical phenomenon called the Moiré effect, which occurs when two repetitive patterns are superimposed, illustrated here with two window meshes, that when one window mesh is slid across the other, generates a strong visual pattern. The Moiré effect gives us several benefits because it amplifies subtle movements, which allows us to detect input at longer distances without requiring specialized hardware. Recently, Moiré patterns have been used for camera tracking for various applications like VR, AR, and robotics. This led us to ask if we could invert this, and instead of tracking a camera, we can use the Moiré effect to track inputs. We introduce MoiréWidgets, which are a set of tangible controls with integrated fringers that generate a Moiré effect to amplify input events. The Moiré pattern emerges when two repetitive patterns are superimposed like these two layers. Assuming that there is no gap between the layers, the emerging Moiré pattern depends on the relationship between the periods of the two layers. For more details on how we calculate displacement with the Moiré effect, please refer to our paper. We use the Moiré effect to keep track of three types of movements: 1D translation, 2D translation, and rotation. We track those movement types and generate a set of 5 widgets, including a dial, a joystick, a slider, a switch, and a button, with colored markers that help us extract and process the Moiré pattern. We developed 2 design tools to let other researchers experiment with MoiréWidgets. The design tool on the left lets users embed the structural components of the widgets onto existing 3D objects, which then could be 3D printed. The processing tool on the right lets users preview various Moiré patterns which can be printed on paper and integrated onto the widgets. We combine multiple widgets to make a simple music controller to demonstrate how MoiréWidgets could be used. Thank you for watching our presentation.